Let's understand center of mass in this video. Have you ever balanced a pencil on your finger and found one spot where it stays steady? That special spot is the center of mass, where the whole weight seems to act. First, a quick note on rigid bodies. They are objects that do not change shape when forces act on them, like a solid metal sphere. The center of mass is a point that represents the whole object or a group of particles as if all mass were concentrated there. For uniform solid objects, the center of mass is at the geometric center. But for a ring, it can lie in empty space at the center. The motion of the center of mass follows simple rules, and external forces act as if applied at that point. Mathematically, the position of the center of mass equals the sum of each mass times its position divided by the total mass. So x coordinate equals the sum of m times x divided by m. This formula works for any number of particles and also turns sums into integrals for continuous bodies. Try thinking of the Earth and Moon. Both move around their common center of mass, which is closer to Earth because it is heavier. Also, if a projectile explodes in midair, its pieces scatter, but the center of mass keeps following the same parabolic path it had before the explosion. Now, let us look at some worked examples to make this clear. Question number 1 asks, two particles of mass 4 kilograms and 2 kilograms are at points 0, 0 and 4, 3 respectively. Find the center of mass. Total mass is 6 kilograms. X coordinate equals 4 times 0 plus 2 times 4 divided by 6, that is 8 divided by 6 equals 1.33 meters. Y coordinate equals 4 times 0 plus 2 times 3 divided by 6 equals 6 divided by 6 equals 1 meter. So center of mass is at 1.33 meters, 1 meter. Question number 2 says 2 kilograms and 4 kilograms lie on a line. The 4 kilogram mass is moved right by 5 meters. How far must the 2 kilogram mass move left to keep the center unchanged? Start with the balance relation m1r1 equals m2r2. So 2r1 equals 4r2, meaning r1 equals 2r2. After moving the 4 kilogram mass right by 5 meters, assume the 2 kilogram mass moves left by x. Substitute into m1 times new distance equals m2 times new distance and solve, giving 2 times x equals 4 times 5, so x equals 10 meters leftwards. Question number 3 has masses 1 kilogram, 2 kilograms and 3 kilograms at the corners of an equilateral triangle of side 1 meter. Find distance of center of mass from corner A. Coordinates are A 0, 0, B 0.5, square root 3 over 2, which is 0.866, and C 1, 0. X coordinate equals 1 times 0 plus 2 times 0.5 plus 3 times 1 divided by total 6 equals 4 divided by 6 equals 2/3, which is 0.667. Y coordinate equals 1 times 0 plus 2 times 0.866 plus 3 times 0 divided by 6 equals 1.732 divided by 6 equals 0.2887. Distance from A equals square root of x squared plus y squared, which equals about 0.727 meters. So that is the required distance. Now for continuous bodies, a uniform rod of length L has its center at L divided by 2 from one end. Simple, because mass is evenly spread. A semicircular ring of radius r has its center of mass at height 2r divided by pi above the base center, while a uniform semicircular plate has center at 4r divided by 3 pi. For a solid cone of height h measured from the vertex, we consider thin discs, write dm proportional to y squared dy and compute y-coordinate as the integral of y dm over total mass. Carrying out the integrals gives y-coordinate equals 3/4 of h measured from the vertex. So center of mass lies at 3h divided by 4 from the tip. Question number 4 used this disk method to reach the same result. So, integration for symmetric solids is straightforward once you set up the slice properly. Question number 5 asks about a 4 by 3 meter rectangular sheet, mass 24 kilograms, with a 1 by 1 meter square cut from a corner. Find new center of mass. Treat the step 1. We begin by establishing a coordinate system. Let's set the origin point 0, 0 at the bottom left corner of the shape. Step 2. We need to identify the mass and center of mass for both the original full sheet and the square that was removed. The original 4 by 3 meter sheet has a total mass of 24 kilograms. Because it's a uniform rectangle, its center of mass sits exactly in the middle. That's an x-coordinate of 2 and a y-coordinate of 1.5. Now, let's look at the removed 1 by 1 meter square in the top right corner. Its area is 1/12 of the total sheet, which means its mass is 2 kilograms. The center of this removed square is located at an x-coordinate of 3.5 and a y-coordinate of 2.5. Step 3. We can now calculate the new center of mass for the remaining shape, which has a new mass of 22 kilograms. We will do this by subtracting the moment of the removed part from the moment of the whole. Let's find the new x-coordinate. We multiply the total mass by its original x-center, subtract the removed mass times its x-center, and divide it all by the remaining mass. That gives us 24 times 2 minus 2 times 3.5, all divided by 22. This simplifies to 41 over 22. We use the exact same process for the new y-coordinate. We take 24 times 1.5 minus 2 times 2.5, all divided by 22. This simplifies to 31 over 22. And there we have our final answer. The new center of mass is located at the coordinates 41 over 22 meters and 31 over 22 meters. Question number 6 gives a car 1500 kilograms east at 20 meters per second and a truck 3000 kilograms west at 10 meters per second. Find velocity of center of mass. Taking east positive, total momentum equals 1500 times 20 plus 3000 times negative 10 equals 30,000 minus 30,000 equals 0. Divided by total mass 4500 gives 0. So center of mass is stationary. Question number 7 with a man of mass m on platform mass m on smooth ice. Man moves relative to platform with speed v. Find recoil speed v of platform relative to ice. Use conservation of horizontal momentum. Initial momentum 0. Final m times open quantity v minus v close quantity plus m times open quantity negative v close quantity equals 0. Solve for v to get v equals m times v divided by m plus m. So, what do we learn from this? The center of mass simplifies many problems. It moves as if all mass were concentrated there and only external forces change its motion. Let us quickly remember the main points. For particles, RCM equals sum mr divided by total mass. For rods, center is at half length. For semicircular ring and plate, heights are 2r divided by pi and 4r divided by 3 pi respectively. And for a cone, it is 3h divided by 4 from the vertex. Keep practicing setting up sums or integrals and remembering symmetry to save work. Thanks for studying with me today. Keep your curiosity alive and feel free to explore more lessons on EduRev to practice these ideas in depth. Good luck and keep solving problems step by step. You are doing well.